Welcome to tutorial 9. Today we'll be working on the second part of assignment 5. If you are listening to this in the tutorial in the computer lab, please make sure to silence your audio so that you're not disturbing the people around you. There are closed captions. The option to turn those on should appear near the bottom of the video. And like I said, we'll be working on the second part of assignment 5, and in that part of the assignment you are required to join a layer to a polygon layer and calculate some summary statistics. Now I'm going to show you how to do this in both QGIS 2.18 and QGIS 3.6. There's a different technique depending on which version of QGIS you use. We'll start with 2.18 since that's what's on the lab computers. Now I'm going to use a different data set so I don't give away the answers. Let me start by adding an OpenStreetMap base map here just so we can get a sense of where we are. Little geography lesson for you. Looking at some building footprint data in Cincinnati, Ohio. You'll be up there in Toronto. This data is pulled right out of OSM. What we have here are building footprints in gray and business districts in red. We've got 5 business districts and quite a few buildings. I'll just turn off this base map. Now what I'm going to do is I'm going to calculate the area of the buildings, so the total square foot of the footprints of the buildings, or square meters of buildings per business district. I want to know how much building is in each business district measured in terms of area. Now area is an attribute on the buildings. We've got an ID number and we've got the area of the way. I think this is probably in square meters, but it doesn't matter for the purpose of this exercise. Now notice that our business districts, and there's only 5 of them, have the same schema. We have an ID and we have a way area. The way we're going to do this is we're going to go to Vector and Data Management Tools, and we're going to join attributes by location. Now the way this tool works, and it's documented to some extent over here on the right, is that we have a input layer and a join layer, a target vector and a join layer. Our target vector here we're going to use as NBDs, and our join vector layer is going to be buildings. Now when we do a spatial join, we're matching 2 records in different tables based on the location of their geometries, and this is going to produce one geometry. So we have 2 geometries that match, the building footprint and the neighborhood business district, and we only want to keep one of those because it's difficult to represent a record with 2 geometries. And selecting NBDs as the target layer means we're gonna keep these business districts geometries, but we're gonna add attributes from the buildings layer to those geometries. Let's go with intersects. We want buildings that intersect with our NBDs. And we have the option of either taking attributes from the first located feature, so any arbitrary building that intersects those geometries, or we can take a summary of intersecting features, which is what we want. Now it defaults to giving you all these summary statistics: sum, mean, min, max, and so on. Let's just look at sum. I'll delete those. We'll keep matching records, and I'm going to hit run. So what we have in our joined layer is just added to the map. Let me use the identify tool here. Is we have a new sort of repeated business district geometry, but we've added 3 extra fields to it. So we have sum of OSM ID. You can see it's just prefixed sum to that field name, sum OSM ID. And we have this big meaningless number that's a sum of the ID numbers. And we have sum of the way area. So this is the sum of the areas of those building footprints. So this is our meaningful number. This is what we're after. Now it also gave us a count. So you can see here that this business district has 92 buildings intersecting it. Let's take a look at one of these. This one has 13, a bit smaller. And we can color these or style these according to that attribute, because we now have that attribute actually in the table. So let's just go to graduated. We'll give it that some way area field, classify, and now we're using color to show how much area from those buildings is intersecting those business districts. It's real simple. That's how you get the results. Now I'm going to show you how to do this in later versions of QGIS. If you're just going to do the assignment in 2.18, you can feel free to go ahead and check out the way of doing this in QGIS 3.6, which I'll be showing you, is a bit more complicated. Here we have the same set of buildings, the same business districts. We're going to do the same thing essentially. Now, the difference is that over here in Data Management Tools, Join Attributes by Location, we've got a different tool here, a different dialog box. It doesn't give us the same options. Let's try and do the same thing. Input layers are business districts, join layer is buildings, intersects. I'm going to take the intersection. Our join type is going to be one-to-many, so instead of taking, notice that this doesn't give us a summary option. So we either have the option of taking an attribute from the first located feature, or we can create a separate feature for each located feature, which means we're going to end up with a lot of results. So if we have, for example, 5 business districts and each one intersects 100 buildings, we're going to get 500 results, okay? And there's going to be a lot of repeated geometries. So we'll create a separate feature for each located feature. I don't think we need to fill out the rest of this. The defaults should all be good. I'm going to hit run. Takes just a second. That was a slightly bigger ask. I'll use the identify tool to show you an interesting thing here. So I select this business district in our joined layer, and what I actually get is a lot of different features. We should actually have 13 features here, because remember that this business district matched to 13 buildings, and that geometry is just repeated a lot of different times. It's just there's 13 polygons layered on top of each other here, and each one has its own OSM ID, the OSM ID of one of the buildings that match to it, and the way area of that building. So this building had 359, let's say, square meters, and this one, different building ID number, different size, right? So each one is different, represents the same business district, different building. I'll just close that. And let's just take a look real quick. Basically, in the attribute table of this join layer, we have the OSM ID of the business district, the way area of the business district. A lot of these are repeated over and over again as they're joined on many different buildings with different areas. The way to resolve this, you might guess from what we've covered on SQL, would be to use an SQL query with an aggregate function and a group by statement. And that's exactly what we're going to do here. Even though this data isn't coming out of a PostGIS database, it's actually just layers in QGIS. Let me just rename this here, because it's going to make this a bit easier in a second. I'll just call it JL for joined layer. Now what we're going to do is we're going to create a layer, a new virtual layer, and what this new functionality does is it essentially lets us build a new layer from a SQL query that lets us use as tables anything that we have in our layers dialog, anything that's currently on the map. And there's a few special functions that you can use relating to geometry as well. So what we want to do is select our OSM ID. Remember, OSM ID refers to the first table, and OSM ID 2 refers to the buildings table. Select OSM ID. I'm going to select what is called a geometry field, which we reference here with this special JL, that's the table name, .geometry. And then I'm going to use an aggregate function, max of way area 2. Sorry, not max, sum. Right, so there's our select statement from that joined layer, which I called JL. And we're going to do a group by, remember we have to group by everything except the aggregate function. So OSM ID and JL.geometry. Yeah. Let's double check this. Select OSM ID, JL.geometry, sum of way area 2, that's the building area. From JL, group by, yep, that looks correct. And let's click add to add that to the map. Now, a little hard to see because the color is very similar, but I've just added a new layer. It's called virtual layer. And let's just use the identify tool again to see if we've done the right thing here. So this shows exactly the results of our SQL select statement, except it's not giving us the geometry attribute here in this table. The geometry is actually shown on the map. So we have the OSM ID of the neighborhood business district. Let's just double check. That's 2929 something something. Let's go back to this original layer. 2929, yeah. So we've got the NBDs in the right place. We've got the right geometries, the same as the original geometries. But what we have now is this, oops. What we have now in this new virtual layer is this summary statistic of the areas of the joined buildings. And let's just verify that we have exactly the same results as we saw before. I'm just going to render this as a graduated variable. I'll use that sum field, classify. Let me close that side window. And again, you can see we've got this big business district over here with the largest area of intersecting buildings. These two at the least, and those two in the middle. So it looks like we got the same result. This number looks familiar from the previous, from QGIS 2.18. So we've got the same result doing this in a slightly different way. So that should be all you need for the assignment. Remember, you're going to be using Toronto data. Follow the assignment instructions to complete that. Also make sure that you look at the tutorial instructions. There is still a submission for the tutorial even though we're working on the assignment here. You'll need to submit a map that's very similar to what you're doing for the assignment but just a little bit different. So make sure you follow those instructions carefully.